Okay, let's work pathways 4.16 and 4.17 out of your book because these two deal with exactly the same concept. You're asked in these problems, do aqueous solutions of the following compounds conduct electrical current? This problem is basically asking you, if you take these four substances, these are 416, this is 417, but if you take these substances, you throw them in water to make an aqueous solution, and they dissolve, will the resulting solution conduct an electrical current? Right? Oftentimes you'll see pictures in textbooks or exams, homework problems that look a little bit like this, where there's electrical circuits and they're actually kind of testing you on the same idea, just in a different way. If you see a picture like this, you'll see a solution in a beaker. There's probably a couple of electrodes with some wires to a battery and maybe even a light bulb. And in some cases, that light bulb might be lit and bright, and in some cases, it might be dim or turned off. And that is supposed to give you information about how much current passes through the circuit. Okay, now, if the light bulb is very bright, if it's turned on, that means that current can freely flow through the circuit, through this solution, and that would be indicative of a strong electrolyte. If this light bulb is off completely, dark, that would tell you that the electrical current cannot flow through this solution. That would be a non-electrolyte. And perhaps the bulb might be a little bit dim. In such a case, that would be a weak electrolyte, somewhere between the extremes. But in any case, we're getting down to what really matters, and that is, can electrical current, be conducted through a solution of these substances? Now, the key bit of information is that if current is going to be conducted, I must have a large quantity of ions floating around as ions inside this beaker, meaning that my compound that dissolves needs to dissolve in water, and it needs the ions to separate or dissociate from one another. It needs to be ions, and those ions need to become hydrated inside the solution. If that occurs, the solution will conduct electricity quite well. If it does not occur, we will not have a very good conductive solution. Okay. So let's just kind of dive in and work through this. So the first one is cesium bromide. This is an ionic compound made from a metal and a non-metal. That's what you should recognize immediately in problems like this. Okay. Ionic compounds, generally speaking, if they are soluble, will dissolve in water to form ions. The reaction that basically happens is the solid will be placed into liquid water, and the ions are said to dissociate or separate from one another to make cesium +1 and bromide -1. In both cases, those are AQ, or aqueous ions. Whenever you see the AQ, that tells you the water is surrounding. Now this is significant, because if I make isolated ions that are surrounded by water molecules in this solution, I've met the condition for being a strong electrolyte. And in such a case, that solution is going to conduct electricity. Now the next one is HI. If I put that in water, I make these ions. You may remember that HI is on our list of strong acids. So if I bubble that through water, I make hydrochloric acid. I'm going to make ions. This is also an example of a way that I can get to ions in solution. Also an example of a strong electrolyte. Any route to making a large concentration of ions in solution means the solution will conduct, and that material is said to be a strong electrolyte. Moving on to the next one. This is the next problem now. We've got potassium sulfate. Potassium salt's generally very soluble. So if this one goes into solution, I make the sulfate polyatomic ion, also aqueous, and the potassium ion. aqueous. 2 copies of that by virtue of this 2. This is also a strong electrolyte because I've made these ions. Right, so the moral of the story is that if you got an ionic compound that is soluble or a strong acid or base, you've got a strong electrolyte. Okay? Now, part B on question 417 is a little bit different because here we're dissolving sucrose. This has the formula for sucrose. Sucrose is just sugar. Now, if I put sucrose in water, it turns out it will dissolve. Okay? But the thing is that when sucrose molecules dissolve in water, there's no ionization or breaking apart of ions. Sucrose is a molecular covalent compound. I can get it to dissolve into water, and everybody's seen that, right? If you throw some tablespoon of sugar in water, you can get it to dissolve. Doesn't mean it disappears. It's still there, of course. And the sucrose molecules are still surrounded by water. They're floating around in the solution that's made. But the important difference is that for covalent compounds, non-ionic but covalent, these tend to not ionize when you put them into solution. And as a consequence, we can get sucrose to dissolve, but it's not an ion. And since it's not an ion, it cannot conduct electricity. So sucrose, or any other sugar for that matter, is a non-electrolyte. Not going to conduct current. So we've seen that non-electrolytes are kind of the realm of these covalent compounds, and strong electrolytes are the realm of ionic compounds. So what makes something in this middle category, then the weak electrolyte? I think for that weak electrolyte, where the current will be conducted very weakly, or maybe this bulb is very dim if you have a picture, for that, go searching for ionic compounds that are only sparingly or slightly soluble, or else very weak acids. Things that don't ionize or dissolve to a appreciable, a very large extent. Okay, so there's that third class of compounds. We tend to call those weak electrolytes. So those are some hints. Okay, but an important type of problem. I went over this. It's a little bit difficult, I think, for students to maybe get it in some cases and understand what this light bulb is and how that corresponds to these terms. So I went over it for that reason. It's also kind of easy to give, a question on the exam about this. I don't know that you'd get more than one question about this particular concept if you get any, but I wanted you to be prepared and heard this story if you in fact see something like that on a further exam.